All right, so what we're doing is that we are going to start quatics, and as I'm explaining quatics, we will generalize the rules to draw the graph of any polynomial, right? Whether that's quatic or any higher degree polynomial. So I'm just going to give you fundamentals of how you graph, be it any degree, right? Be it linear, parabola, which is quadratic, cubic, quartic, and so on, right? 5 degree, 6 degree, 7 degree, anything. Now, let's quickly talk about those general rules first, and then we will apply those general rules um, to then graph quatic, right? So very basic rule is even degree polynomials and odd degree polynomials. Now, even degree polynomial means the power of 2, which is x squared, power of 4, and so on. Odd degree odd degree polynomials are linear, which is x raised to the power of 1. We don't write 1, so it's x. Then x cubic raised to the power of 5, and so on. Right? So they are called even degree and odd degree polynomials. Now, the polynomials that are even degree, and I think I did talk about it sometime in our previous lessons. The arms of the graph are on the same side, are pointing on the same direction. Think about a parabola, right? Even degree, the basic even degree is y equals to x squared. So that's how the parabola looks like, right? So you have the arms in the same direction, they're going up, which means first and second quadrant, always, always. If you reflect this graph, that means if you place a minus outside it, the arms reflect in the x-axis and they still remain on the same side, they remain in the same direction. So the arms always go together. If it is a reflection, it goes into the third and the fourth quadrant. If it is a non-reflected case, basic scenario, it always remains first and second quadrant. Now let's talk about, so before that, so they have a symmetry, the reflection in the x-axis. So they're symmetrical to the x-axis. The actual graph and its reflection are symmetrical to the x-axis. X-axis is the mirror which reflects the image of the original graph. Is that clear so far, everyone? Basic stuff, right? Now let's talk about the odd degree. The odd degree. So the odd degree, the graph, the arms of the graph are always in the opposite direction. Remember that. For example, linear. Linear is a straight line. So if I say y equals to x plus 1, let's say it's a linear equation, that's how the graph is going to look like. With x-intercept as 1, y-intercept as 1, x-intercept at -1. You see the arms are in the opposite direction, first quadrant, third quadrant. And if I reflect this graph and I say y equals to, and I place a negative in front of it, I have to put the bracket, then this is the second quadrant, fourth quadrant graph, something like this. Second quadrant, fourth quadrant. Always remember that. right? Now, if you look at another odd degree graph, y equals to x cubed, it is a point of inflection, you see here. That's how it is. First quadrant, third quadrant. And the other forms of cubic that we discussed last time, so x cubed, if there's a general form, I've just made up something. It will have something like this. So there are two shapes of cubic. Still here, you have first quadrant, third quadrant. Arms are in the opposite direction. Very, very basic principle. Now, when you reflect this, when you place a minus front, they become a second quadrant, fourth quadrant graph. If I reflect this one, probably that's how it's going to look. Second quadrant, fourth quadrant. If it's a reflection, that means if I have a minus here, the minus outside, right? If that's a minus outside, this reflects in the opposite direction. That is the very, very basic principle of how the shape of the graph and the arms of the graph looks like. Then you have the roots. And I did talk about it last time. If you have a linear root, it simply means it cuts the x-axis. If you have a double root, which means you've got something like this, x plus a square. You've got a double root. It touches the x-axis and stays in the same quadrant. What does that mean? If you have x plus a, let's say if you got something like this, x plus a, x plus b square. This is a linear root. So that means the graph will cut. Let's say this is a. And b is a double root. That means it will touch. It will go touch and stays in the same quadrant. It was sitting in the first quadrant, touches, just stays there. One very important observation is if you, and if I maybe use if you just look at the shaded portion that I've just shaded. What exactly this looks like? Is it not a parabola? It's a parabola, right? And what is a parabola? A double root. Parabola is a double root polynomial, right? So whenever you have a double root, your graph will create a parabola. Always remember that, right? It's kind of, right? Whereas if I change the color here, maybe look here. Look at this portion of the graph, just this portion, the green portion. Green portion is more like a straight line. It is a linear root. Linear is a straight line. That's why it is cutting. Am I clear? So we can chop our graphs into linear and a parabola, kind of a view, and they can join together. The third is triple root. And that's the last one. The triple root. Triple root means you've got x plus a cube. This creates a point of inflection. That's about it. That means If that's A, so the graph will be, that's the point of inflection. Now, all polynomial graphs are just a mix of these three roots. That's about it. And if you understand that, then you can graph any root, any graph. The basic shape can be created. Let's try them. Let's try one. Now, also, one more important point here in the double root scenario is if this is double, double simply means the even root. So if that means if I have x plus a raised to the power of 4, that will also create a parabola, a U kind of a shape. Just remember that. Double or even, should I say. Even power. Okay? Now let's try that. Let's say I have a quartic y equals to, I'm just hypothetically making some, 2 x plus 1, x plus 3, maybe I'll take a minus 1 plus 3 plus 5 plus 7. So you've got 1, 2, 3, 4. This is a quartic, right? 4-degree polynomial, 1x, 2x, 3x, 4x, x is power of 4. What kind of root is this? Linear root. That means a cut. Cut at x equals to 1. Cut at x equals to minus 3. Cut at x equals to minus 5. Cut at x equals to minus 7. Let's do it. That is 1. So let's say this is 1, 2, this is 3, 4, 5, this is 5, 6, 7, 7. So I'll start anyway. And this is a quartic and there is no negative sign in the front. So it simply means that the arms will be on the in the first first quadrant and second quadrant, same side. It is even degree. Let's create it. Even degree at, so I have a cut. This is a cut here. Done. Between two cuts, you have to turn to return back to the second point. Cut, cut, cut. That's the quartic. 4 cuts joined together in the form of a loop. Graph is done. Created. Finish. Now, if I say, let's take another example. Y equals to x plus 2 square, x minus 2 square. Still a quartic. Now I've got a double root. Let's do it. This is 1, 2, minus 2, 1, 2, positive 2. What am I going to do? There is no negative in the front. So that means the graph will be in the first and second quadrant. I come here. Now this is a even. So I have to touch. I have to touch. To touch. I come here. I touch. I turn back. I touch. And a quartic is created. Is this clear? Everyone, what am I doing here? This is the simplest version of graphing any damn graph that you have with hand. Obviously, with respect to intercepts, etc., you have to do calculation. But the moment you see a graph which is specially factorized form, your mind should tell you straight away what it should look like. If I have a negative in front, then you have something like this. Reflection, simple. Now let's take an example of a triple root. So let's say now you have y equals to, let's say, x plus 1, x minus 3 cube. Still a quartic? Yes, everyone? Let's draw it. 1 minus 1 is over here. 1, 2, 3. This is a cut. This is a point of inflection. Let's do it. And there is no negative in the front. That means the arms will stay in the second and the first quadrant. I come here and I cut because that's the linear factor. And I go back and there's a point of inflection. This is also a quartic.
So
Any question?
would the point of inflection be at 3?
Yes, because that has the power of 3. Everyone's clear with this? This is graphing at its fundamental and simplest level of consumption. Now, let's try another one. Y equals to, let's say, 2x minus 1 raised to the power of 4. So I've taken all the variations of a quartic. I took all the linear factors, then I took a double root, then I took a triple root. Now I'm taking 4 roots. I told you here, look at my rule. Even or double root is a touch, a parabolic touch, right? So this is one. How this is going to look like? Come here. Now, the bigger the degree goes, the even degree, as the even degree goes higher, the parabola starts to dilate more. So if, for example, I'll change the color, if this would have been a 6, let's say this was not even a quartic, this was a 6-degree polynomial. How would this look? This will look something like this. The mouth starts to become even more wider. Right? That might not, I mean, I can probably, that's how it's going to be. But then you know basically how it is going to. It's still a U pointing in the same direction. Now I have, this is a 6-degree polynomial. Mind you, this is not a quartic, this is even 2 degree up. All good, clear with this one? Let's do another version, right? Let's do another version. Let's mix. Let's say y equals to x plus 3 and x plus 1, x minus 2 square. Quartic. Linear root, double root. Cut, cut, touch. Now I tell you this cut, touch and a touch, cut is just my terminology, right? Right. So just do it in your head, right? I don't know whether your teacher is going to tell you that, but then that's how my brain decipher it, right? Okay, let's quickly do it. 1, 2, 3, minus 3, minus 1, 1, 2, 3, plus 2. All right, let's cut at minus 3. And there is no negative, so that means first quadrant. Sorry, second quadrant. Let's place a minus here, right? Let's do a sum. So if a minus is there, that means this is a third quadrant, fourth quadrant graph, a reflection. Cut at minus 3. Cut at minus 3. Cut at minus 1. Loop it. Cut at minus 1. A double root at 2. Go up, loop, touch and come back. Quartic done. Am I clear? Yes? No? You're fine, right? Everyone's okay. I mean, this might not be sort of the perfect one. I can maybe draw something like this. That's the fourth.
So this is like the one if there's a negative in front, right?
Yes.
Yeah,
Reflection.
okay. Yeah, reflection, okay. So if there's a negative in front,
If that means the second, the third, and the fourth quadrant. If
okay.
there is,
So
if this is positive, if this was would have been a positive, that means no negative. Then you would have said cut, turn back another cut, touch and go.
all right, so if it's a positive, it just goes to 1 and 2 quadrants.
1 and 2.
Yeah.
If it is a
It's
negative,
a
3 and
negative
4.
3 and 4. Okay.
Simple.
Yeah.
That summarizes graphing. You can graph any damn polynomial if you are given a factorized